Okay, titration practice here. We got a 15 milliliter sample of acetic acid, which acetic acid is HC2H3O2, is titrated with sodium hydroxide. Okay, here's the key here is that this is all 1 to 1. So this is a +1, -1, +1, -1. So it's all 1 to 1. I don't even need to do much else beyond this. So this is going to be 1 mole to 1 mole. Okay, and so we know that we've got acetic acid in here. So we've got our 15 milliliters right here. And then we used 23.12 milliliters of this 0.994 molar NaOH. Okay, so we know that this one here is 0.994 molar. So basically, if we knew how many moles were in here, that's the same number of moles that interacted here. So if we're working backwards, we really want to know the molarity of this stuff. So that means we want to know how many moles there are of the acetic acid, I'll just call it HA, in 1 liter of acetic acid. Call it HA again. Okay, and I already know how many liters this is. It's 0.015 liters. And all I really need to know is how many moles of acid there were, because again, 1 to 1. So we can figure out how many moles there are in here. So let's say we've got for every 0.994 moles of NaOH, there is 0.02312 liters, and for every blank moles of NaOH, there is this is 1 liter, and this is 0.02313 liters. So we're just going to multiply by 0.02313, which is about a quarter of that. So this should be 0.021, let's say. So this is about 0.021 divided by 0.015 divided by 0.015. This comes out to be about maybe 1.2 molar. What am I saying? It's 1.4. There we go. There's our final answer. Okay, number 2, what volume? This time we're looking for volume. Of 0.87 sulfuric acid. So let's write that down. We got H2SO4 plus strontium hydroxide, SrOH2. So we get HOH and SrSO4. Changes this to a 2. I'm going to just disregard all of this. It's all balanced now. So it's still a 1 to 1. Okay. All right. And so I'm just going to disregard all that. And let's erase it, actually, if I can. Or not. So let's go ahead. Now this time we've got 120 milliliters in here of 0.225 molar. This is the base down here. And up here we've got sulfuric acid. That's 0.87 molar H2SO4. Okay, so we got 0.87 and we got 0.225. So again, if I knew the number of moles here, I could figure out the number of moles here. And we just want to know how many liters of this. So really our question mark is right there. All right, so let's say that we know for every 0.87 moles of H2SO4, there is 1 liter of H2SO4. And so we want to know the number of liters to interact that need to be pulled to get that many moles. All right, so this is, we need to find this so that we can find this. And so we're going to use this information here. So let's go ahead and use this right here. So we've got for every 0.225 moles of SROH2, there is 1 liter of SROH2. We don't have 1 liter, or else we'd know our answer already. We have 0.12 liters of SROH2 solution. So we got times 0.12 times 0.12, and that comes out to be 0.027. Now, we said already, this is a 1-to-1, so we don't have to worry about anything. The same number of moles here, right, that came out, that needed, or started with here, are the same number of moles that we needed to pull from here. So this is going to be 0.027. So to get from here to here, we're just going to multiply by 0.03 times 0.03. This comes out to be 0.03 liters, which is 30 milliliters of H2SO4. Number 3 has a bunch of big words in it, but they're no big deal. Diprotic just means 2-proton acid. Protons are just H's. So H plus is just a proton. And let's just write down, we start with 16.22 milliliters of this, and it's 0.5030 molar. And then of the H2X, we're using 18.41 milliliters. And we want to know the molarity of that. So in terms of the acid, we really just want to know for every blank moles of H2X, there is 1 liter of H2X. Okay, and we know already the liters, so we're halfway there. We know that it's 0.0184 liters of H2X. Okay, and then in the KOH, we know that for every 0.5030 moles of KOH, there is 1 liter of KOH. Okay, and then we've got for every blank moles of KOH, there is 0.01622 liters. 0.00816. It's about half of this number here. All right, now this is the amount of KOH, right? And if I think about that, that's 2 times as much of the acid. So that's going to be half of that half to give me the amount of acid. So this is going to be 0.00408. And then, so to get from here to here, we divide by 0.0184. And this will come out to be a bigger number because we're going to do the inverse when we multiply. And that comes out to be 0.222, which is about half the molarity. So just think about it this way. This started off with almost the same volume. This is 0.5, and this is half the concentration because it's a 1-to-2 ratio. Our next problem is just a titration problem, even though it sounds kind of outlandish. We've got HCl, we've got hydrochloric acid, and calcium hydroxide, so CaOH2. That goes to HOH and CaCl2. So this is 2, and this is 2, and I think we're good. So realistically, what we just found out, we don't need this anymore. What we just found out is that this is a 2-to-1 ratio. All right, and it tells us that we want to know what mass of calcium hydroxide should we send. So we're going to send some solid of this. All right, so we can say, give us the density of this stuff. So we're going to say, for every 1.1 grams of HCl, there is 1 milliliter of HCl solution. So we know that this is 2.8 times 10 to the 6th grams of HCl. And to get there, we're going to multiply by 2.8, quite 2.8, it's 2.55 times 10 to the 6th. So that means that this is 2.55 times 10 to the 6th milliliters, which is 2.55 times 10 to the 3rd liters. Okay, this is of the HCl. All right. And then they tell us that it's 6 molar, so that means that for every 6 moles of HCl, there is 1 liter of HCl solution. And we don't have 1 liter. We got a lot more. We got 2.55 times 10 to the 3rd liters of HCl solution. So this is times 2.55 times 10 to the 3rd. This is 15.3 times 10 to the 3rd moles. Okay, and don't forget that that is the moles of HCl. So now, if this is 15.3 times 10 to the 3rd, then that means that this is half that amount because this is a 1-to-2 ratio. So this is going to be 7.65 times 10 to the 3rd moles of this. And then, this is actually really easy, this last part. So now we're just going to take that. We're going to say for every 1 mole of CaOH2, there is 40 plus 32 is 72 plus 2 is 74 grams of CaOH2. And then for every 7.65 times 10 to the 3rd moles times 7.65 times 10 to the 3rd, that is 566 grams of CaOH2. That's the end. Sorry for any screaming in the background. Those were my children. Have a good night. Bye.